Hello everyone, welcome back to chemistry class. Today we're going to be talking about the model of the atom that we use today, and that is called the quantum mechanical model. It's a little bit more complicated, but it still holds a lot of the same things from Bohr. So chemists still believe that electrons orbit around the nucleus and that there are many orbits that they can jump between. We still say that electrons need energy to go into orbits and release energy in the form of light to get back to orbits closer to the nucleus. And we assume there are only certain energies that an electron in an atom can have and nothing in between. Now, where the quantum mechanical model differs is the type of orbits that the electrons can occupy. So in the Bohr model, electrons orbit the nucleus in circular orbits. And in the quantum mechanical model, we assume that electrons orbit in clouds that we call orbitals. So electrons can at different times be at different distances from the nucleus, but still be in the same orbital. So you can think about it like a dog tied to a stake. The dog can go anywhere within the circle, but can't go outside the circle. Also, the orbital has a general shape, and the electron can be anywhere within that shape. The other difference between Bohr's model and today's model is the shape of the orbitals. So in Bohr's model, the electrons orbit in circles, but in the quantum mechanical model, there's a lot of different shapes that you're going to see, and some of them can be very complex. So we're just going to focus on the very first three, which are the most important. Okay, so this is the first one, and it's the simplest type. We call it the s orbital. It is spherically shaped with the nucleus at the center. So notice that there's three s orbitals with different sizes, and this is because electrons can orbit far away from the nucleus or close to it, depending on their energy. In the Bohr atom, the orbit number 1, 2, and 3 determined how far they were from the nucleus. And so this is in the same way, it's the same idea. This model allows electrons to orbit far from the nucleus or close to it. And the number means it can be farther away. Or the higher the number, the farther away. That's what it means. So if the electron orbits far away from the nucleus in a spherical pattern, it will occupy a large s orbital. And if it orbits close to the nucleus in a spherical pattern, it will occupy a small s orbital, like a 1s. So a 1s is smaller than a 2s, which is smaller than a 3s. And electrons in a 1s orbital have less energy than electrons in a 2s orbital. The numbers that appear next to the orbital letter is called the energy level of the atom. So the numbers 1, 2, and 3, that's the energy level. The higher the number, the higher the energy. The lower the number, the closer to the nucleus. Okay. The next orbital shape we're going to talk about is the p orbital. And this is dumbbell shaped with the nucleus at the center. And there's different sizes of p orbitals that correspond to different electron energies. None of the p orbitals are on the first energy level of the atom. So there's no such thing as a 1p orbital. The first p orbital is the 2p orbital. For every energy level, there are actually 3 different p orbitals. And they're all shaped the same, but they're oriented differently in space. One is oriented horizontally, one is vertically, and the third is oriented 90 degrees from both of the others. So this may look a little new to you because most of you have not seen the z-axis. But when you get to higher levels of math and that sort of thing, you start working with things in 3D, which gets a little complicated, and that's where the z-axis comes in. It kind of helps you view things in a 3D way. So there are 3 2p orbitals. There's 3 3p orbitals, and those are bigger than the 2p orbitals. And there's 3 4p orbitals, and so on, and those are slightly bigger than the 3p orbitals. So anyways. And the last type of orbital that we're going to talk about for this course is the d orbital. The shape is very complex, kind of looks like a 4-leaf clover. There are 5 different d orbitals for each energy level. The lowest energy, or the smallest d orbitals, are located on the 3rd energy level. So the first set of d orbitals is the 3d orbitals. Since they have more complex shapes, they require more energy than either the s or the p orbitals. So the lowest energy of all orbitals is the s orbital. And the highest for this class is the d orbital. Now, each individual orbital can only hold 2 electrons. After 2 electrons, the orbital is full, and any new electrons must find another orbital to fill. Since there are 3 different p orbitals on an energy level, 6 electrons could fit into all 3 p orbitals on that energy level, right? Because it's 2 per orbital, and if there's 3 of them, 3 times 2 is 6. And since there are 5 different d orbitals on an energy level, then up to 10 electrons can go into the d orbitals on a given energy level, because 5 times 2 is 6. If an electron is orbiting as close as it can to the nucleus, we say that it is in the 1st energy level. And on the 1st energy level, only the s orbital exists, right? There's no 1p or 1d. Only a 1s exists. So if it's that close, then it must do so in a spherically shaped orbit, the 1s orbital. Now, if the electron goes up to the next energy level, it's a little bit farther away from the nucleus, and it has the option of orbiting the nucleus in a spherical orbit, the 2s orbital, or in any one of the 3 dumbbell-shaped orbits, the 2p orbitals. Now, if the electron goes away from the nucleus even further to the 3rd atomic energy level, then it has the choice of a spherically shaped orbit, the 3s orbital, one of the 3 dumbbell-shaped orbits, the 3p orbitals, or one of 5 more complex orbitals, the 3d orbitals. Okay, so this is just a summary of what we just talked about. So the atom has a nucleus of tightly packed protons and neutrons, and its electrons whirl around that nucleus in several different energy levels. And depending on the energy level, the electrons have several different shapes of orbitals, s, p, d, and there's some others, that they can use to travel around the nucleus. Each specific energy level has its own requirements for the electrons, and each orbital shape has additional energy requirements. And based on the energy the electron has, it will go into the energy level and orbital whose energy requirements it best meets. And each orbital has a max capacity of 2 electrons. That's very important because we're going to be using that for electron configurations starting tomorrow. All right, we'll see you guys tomorrow.